If you're finding yourself needing to change your screen resolution frequently and you are getting tired of all the steps it takes, then in this video I will show you how to use Python to create a simple application that lets you change your screen resolution quickly with just 2 clicks from the system tray. Hi everyone, welcome to my channel. If this is your first time visiting my channel, here I mainly share content about programming, such as tutorials on different programming languages and new technologies. I also share about tips and tricks when using computer and softwares, along with various tech-related topics.
Back to the video, here's the breakdown of what we will cover. First, we will set up the necessary Python packages before we dive in. Next, we will try setting the resolution for primary screen. Then, we will level up a bit by setting resolution for multiple screens and adjusting their positions. And finally, we will create an application icon in the system tray for quick access. At the end of the video, I also explain why I need the solution, so stay tuned. I'm using Visual Studio Code in Python 3.10, but you can use a different IDE or another version of Python as well. Let's get started. First, we will check and install necessary packages. To make things easier, I will open VS Code and use its terminal so you can follow along more easily. Press Ctrl+J to open the terminal inside VS Code. We will use Win32 to interface with Windows, including setting display devices and then resolution. Use this command line to set up a package. Here, install Win32, then hit Enter. Since I have changed the names of the Python and pip executables on my computer to include 3.10, so I need to type 3.10 in my comments. But if you haven't done this, just type pip or pip3 will work fine for you. We also need pillow and pystray to make our application run in the system tray by the command pip install pillow pystray. All set. Now let's test to see if we can change the resolution or not. Let's start by creating a new Python file. To switch the language mode, press Ctrl+Shift+P, type change language mode, hit enter, and then choose Python. First up, we need to import the module Win32 API, Win32con, and PyWin types. These modules are essential for interacting with Windows devices using Python. We will write a main function for our script. Now, we'll create a dev mode object using the dev mode type from Win32. This object represents the display that we want to adjust the resolution for. We will modify the width with pulse width and the height with pulse height. Since we change both of the width and the height, we need to include these changes in the fields attribute using the OR operator. This tells the system what settings we're updating. Finally, we call the Win32 API change display settings function and pass in our dev mode object. For the flags, we use 0 to indicate that the changes should take effect. If the result is anything other than display change successful, it means the screen resolution wasn't changed successfully. In that case, we will write an exception with the message failed to change the screen resolution. Alright, now press F5 to run our script. I will save the file in the desktop. Select Python debugger and choose Python file. You should see our screen resolution has changed. This script currently changes the resolution only for the primary screen, so if you're using multiple screens and want to adjust the resolutions for different ones simultaneously, we need to improve it a bit. I'm going to move this code into the function that takes 3 arguments: device name, width, and height. And instead of calling change display settings, we will use change display settings x. This function allows us to specify which device we want to modify by passing the device names along with the dev mode object. We also need a function to list all active display devices, so we can get their names and pass them into the function created earlier. We will use Win32 API enum display devices for this purpose. For each device, we check the state flags to determine if it's active, and we only use those that are active. Back in the main function, we first get all active devices, then we will set the resolution to 2K for all of them. I will open Windows Display Settings. So you can see that I have 2 active monitors and 1 inactive. Alright, let's run the script and see the changes. As you can see, both of my active monitors have now changed to the same 2K resolution. And if you want to change the resolution for a specific device, you need to know exactly which device you are dealing with. So I will put a breakpoint here, and then wait F5 to run the script again. Now in the debug console, we'll bring out device information. The device string will give you a hint about which display device it is. Another option is to try a device one by one. I've already prepared 2 device names for my displays. I'm using these devices. So, I'm going to set the HDMI display to 2K resolution and the virtual one to FHD resolution. I will call the setScreenResolution function, passing the name of the device and the resolution I want. I will do the same for the virtual display. In the Windows Display Settings, you can see that number 2 is my primary display and number 3 is my virtual secondary display, both currently in 2K resolution. Now, I will run the script. And you will see the results. My virtual display has changed to FHD. I've run into a bit of snag when I only want to use 1 or 2 monitors instead of all of them. In the video, you can see that display number 1 is the one I don't want to use. So let's head back to the code and I will add its name first. I came up with an idea where I pass 0 values for the width and height so that it disables the monitor when the script runs. But here's the catch. If I just set the width and height to 0, it will throw an exception because the resolution mode isn't available. So I need to check if both are 0, and if they are, I will set the position X and position Y to bad mode. And since I'm changing the position, so I also need to add it to the fuse attribute. Alright, let's go ahead and run the script again. And there you have it. My number 1 display is now disabled. And because we added the position X and position Y, so I will go ahead to make them arguments in the function so that we can change the screen position if needed. I will move this light off and remove this one. This is my main display, so it's going to be at 0, 0. And I want the virtual display on the right, so position X will be set to the width of the main display. Now, there's one exception to handle. Since display number 1 is already disabled, we can change the resolution for it. But I still want the script to run smoothly without stopping due to this exception. So instead of writing an error, I will lock it. I'm going to import logging and use login.info here with the device name. Let's test it again. everything is okay now. Now let's turn our script into an application that runs in the Windows System Tray so we can quickly access and change the resolution. First, I will import some modules, PyStray, image from Pure, and menu item from PyStray. Back in the main function, I will create some meta items. The first item will set the main monitor to 2K resolutions and the external monitor to HD. The second item will set up two 2K monitors side by side. And of course, we need an exit option. For the exit option, I will set the visible to false and stop the tray icon. Next, I will define two functions for these scenarios. I will also need an icon for my application in the system tray. I prepared an icon in the same folder as my Python file. Alright, let's create an app tray icon. The arguments here will be the names, icon, title, and a set of menu items. Let's run it. And you will see the application running in the system tray now. When you right-click on it, you will have two options for changing resolution according to the scenarios we set up. Now, it's your turn to set up our application to run at Windows data. This way, you always have it ready to change the screen resolution whenever you need. So, why did I write this application? Right now, I'm juggling multiple projects at once, and I want the software I'm working on to always be available, not closed. So, a remote solution meets that need. The remote solution I'm using doesn't automatically adjust the screen resolution when connecting multiple screens. One screen works fine, but for multiple screens, I have to adjust it manually. However, the Windows in default takes too many steps, and it's time-consuming, So, this application will be really helpful for me. Do you want to know how I use the remote solution to work effectively anytime, anywhere? So, stay tuned for my next video.